Hey, welcome back to another episode of Detection at Scale. Today, I'm here with Darren LaCasse, who is the Director of Threat Intelligence, Incident Response, and Threat Detection at Elastic. Darren, how are you doing?
I'm doing great. How are you?
I'm doing well. So I saw recently that Elastic released a new project around detection as code, and I figured that'd be a really great place for us to start because there's a lot of really important methodologies described in there, and I think it'd be important for folks listening to learn about that and to learn it from someone who's close to the company. So why don't we start there?
So detection as code has been something that's been a project that my team's been working on. And recently, as you mentioned, Elastic has released in beta to anyone who wants to take advantage of it. And we think detection as code is important for a lot of reasons. One, especially when you're operating at scale across multiple cloud providers, keeping everything in sync is important, right? Detections, exceptions, and just making sure that you have the coverage you think you have where you have it. And so detections as code allows us to do that, kind of adopting the same principles that our SREs and doing DevOps and everything as code. We can just take advantage of all of the same tooling and all of those same concepts that are already there in those cloud environments, right? So if you think about Elastic Cloud, we have 500,000 plus containers that are running that we're managing detections for, right? And we couldn't do that by hand, right? That would be like artisanal bread making more detections instead of like Wonder Bread just coming off the production line, and it's not sustainable. It also has the side benefit of change control or version control, whatever your auditors like to have. And it's not the most fun or exciting thing to talk to auditors about your detections and how you review them, how often you review them, and what changed. And so it gives you the entire backlog of what happened, who did it, why you did it, when, and you can just quickly pop up, GitHub or whatever your version control system is and show them the changes. And if you're really fancy, you can pick a source of truth and shove detections from your detection engine down into your source control or the other way around, and make sure you don't have drift.
What language are you guys writing in? Isn't it a config language like TOML?
It's TOML, or what the detections are written in. Yep, TOML is it looks like YAML, except I haven't had the same problem with spaces like I do with YAML. It's very, very similar, feels very familiar, and it's easy to read. That was one of the challenges we started out with, started having that led us to build detection as code, is we would export ND-JSON from Kibana. And have you ever looked at NG-JSON? It's like a worse version of JSON when it's time to read it, because it's just lines and like one row of text for each detection, but you have, hundreds of detections, and you can't read that. You can't see where the change is. And so TOML makes it human readable. That's important when you're doing version controlled rules.
So you mentioned a pretty massive scale that you're operating in, and then you used an analogy of having just repetitive Wonder Bread versus handcrafting things. So when you think about the permutations of detections, like what's your approach there for making modifications across your environment? Because I assume that a blanket detection doesn't just work in every part of your environment as is, right? So how do you think about the slight permutations and how do you manage that in code?
Yep. Our cloud environment, that is our SaaS offering, is very static as far as it's the same everywhere. And so that does make it easy. Like everything is managed as code there. And it also, we manage everything centrally. So we have two clusters, two detection engines basically that we have to manage everything in now, instead of one for each region that we operate in and each cloud provider. And then those queries run remotely. So we can do it centrally now instead of having to manage it in 60 places. So we've been doing a lot of things to make the life of a detection engineer and our analysts that have to look at those alerts much easier. We would rather just have one place for them to go, but right now it's two. That's one way we can do it. We also manage using tags. So we can say like, this is a cloud alert or a cloud detection versus an endpoint detection. Because you can imagine we have a lot of developers that run Linux as their primary workstation. And we run the same alerts that we've against our cloud workloads, our cloud Linux workloads on their workstations for two reasons. One is we like to test all of the rules that our product team puts out in production and give them feedback about how well they work, the tuning that might need to happen. But also we find that the same things that happen on cloud workloads also happen on end user workstations when it comes to like oh, they're doing interesting things like exposing port 22 to the internet, and then they get crypto minored or something. And so those same rules apply, but they are not the same like severity. So we do massage the severity or the priority of the alerts based on the source. So if it's coming from an end user workstation, it might be a medium instead of a critical for that same alert. And then they're just tagged differently and come in as a different severity.
So it's on the log level, right? Like the tagging.
The tagging happens after the logs are ingested. So it's our detection engine is kind of adding them in after the fact.
How do you express that logic? Because it's not a rule, right? Is it like a different type of rule? Like how do you guys do that?
So the rules are just looking at the data stream coming in, and based on the source of the data, like of the data stream, that's how we can differentiate. Is it coming from a user workstation or from a cloud workload or from wherever?
It's cool. I mean, I was talking to Josh Liberty about similar types of things where they do on ingest lots of transformations and tagging, things like that. So it's a really similar idea to that, which is cool.
Yeah, I think that method is more efficient for detection engineering, but requires a lot more upfront work and processing, whereas we're maybe being a little more lazy and just getting the data in and then doing that all post-processing.
Yeah, that makes sense. I mean, it's a common pattern too with schemas on read and things like that. So in terms of scale, I mean, how are you guys managing huge amounts of data? Because I know that Elastic is fairly bound by CPU and memory, right?
I have a great team of engineers that run my clusters for me. So one of the great benefits of working at Elastic is I don't really have to think about how much Elastic I consume. We internally brand ourselves as customer zero. And so we spend a lot of time with the engineering team as well. So when we have problems that we experience, we get the folks who wrote the code to kind of sit with us and do the troubleshooting as well, whether it's in the Elastic Stack itself, in the detection engine, in the integrations that we have, all of those things. And so we run 9 clusters now ourselves, and then we have one in each region of Elastic Cloud, at least one, and they're connected via cross-cluster search. So we just have one search head for kind of those 9, and then the like 65 or whatever there are now. We just scale. We run everything internally on Kubernetes. So we use Elastic Cloud on Kubernetes and manage all of that as code. All of the infrastructure monitoring is done as code as well. So we've kind of adopted all of our own internal tooling to just do everything, right? My team has one product that isn't an Elastic product that we use to do detection and response. Otherwise, everything is Elastic or custom built.
It's a pretty nice perk to be able to just tap the engineers and be like, hey.
Yep. I don't even know that we would have to do it, but one of the things we do to also help them is we deploy like the beta candidates, the build candidates in production before they're ready for prime time. We've only had that go bad once, but since everything's managed as code, it's just like hitting a button and everything was back to normal in a few minutes. But so we can help them find bugs at scale that they can't with their test suites. So it's kind of a good relationship that we have too.
Yeah, it's like the best type of testing. So let's talk through about prioritization and focusing on what matters. So what's your mindset around detection creation? Because this has been a hot topic of discussion lately.
I'll say when I first started at Elastic, it was just like, let's build as many detections as we can for what we have data for already. And that was great, right? Like we built a lot of detections and we had a lot of noise. And we were like, this was the wrong approach. But it gave us some insight into what was happening in the environment. And that was 5 years ago. Fast forward to now, a lot of maturity has happened across kind of all of the InfoSec processes within Elastic. And our third-party management program keeps track of all of our vendors, the type of data that they're allowed to handle. So based on our data classification schema and the criticality of that vendor to our business, and if they have the ability to like use our brand as part of how they represent our business or how we use them. So like think of like emailing services or something like that. We now use the criticality of the vendor to the business and the type of data that they are allowed to process. So like restricted, internal, public as kind of the generic guidelines. And we focus on the critical and restricted vendors first. And then if we run into like ties, then if they're able to impersonate or use our brand or represent our brand on our behalf, they get prioritized first. that's how we do the priority. And then what we do, we have a process that we call oatmeal, which is like a friendly way to say threat modeling, but not scare people off so they go running to the hills. Because I've found in previous roles when we say we want to do a threat modeling with you and your vendor, like people just run. They don't want to do that. That sounds scary. And oatmeal is borrowing from the concept of like overlays from the military. Our threat intelligence lead is in the military, and so what we do is we lay out the architecture of an environment. So how do people get access to it? What can it do? Like what data does it have on the back end? And then overlay our control environment on that diagram, and then overlay our detections. And then we go through like, what are the gaps in this environment? How do we make it better? Or how would we make it better? And then we sit down and talk through attack paths. And then we start to focus our detections on the attack paths where we have gaps for those critical vendors. And so it's a real visual way for us to start to show, here's where we have gaps and here's where we're going to focus, right? And if you think about how we do our overlays, left to right is just like the kill chain or MITRE attack, right? So we want to focus as much as we can to the left before the bad thing happens and data's already out the door. Right? You can't put data back in the system once it's gone. And so we use oatmeal as a way to guide that, to have those conversations, and to have something that our internal customers can take back to like our SaaS vendors or even to the cloud service providers and say, we need help with this, right? You don't do logging, as an example. We have some SaaS vendors that didn't do logging or wouldn't integrate with our IDP. And so we were like, we can't actually do business with you. So let's fix this and get you to support our IDP. Instead of just doing local auth for all the things, because we don't have insight to that. You don't get the kind of all of our out of the box rules that you get when you have Okta, right? It's much easier for us if we can get everyone standardized on the same thing, and then we just work our way through restricted critical data or critical vendors, restricted data on the way down, and eventually we'll get to the same level of detail and insights for non-critical and public data vendors, but the focus is definitely on the ones that can impact the business and have data we don't want to lose.
Is oatmeal an acronym?
Yep. oatmeal stands for Overlays and Threat Modeling, Events and Limitations.
Nice. I knew overlays was in there. I knew threat modeling was in there. I was looking at it, trying to just dissect it as you were explaining it. I was like, what does the A stand for?
Yeah, we had an offsite in San Francisco and we were doing threat modeling, and I was like, we need to call it something else. And I was like, let's call it oatmeal. I think I must have been hungry. And so then they squeezed in this acronym, like they figured it out.
And then how do you prioritize, right? Because like going through this gap analysis can result in a ton of things, but where do you point and go, okay, that's first?
That was a challenge at first because it was like everything's the priority because this is critical to the business and restricted data, right? And so once we got through the first dozen oatmeals with different vendors, our most critical of critical vendors, we laid out which oatmeals had the same recommendations, right? So we were able to say like, this one showed up 9 times. Let's focus there because obviously it's going to have the widest impact across all of our surfaces. So let's fix that first. And then rebaseline, like how did that change the attack path? Did it? Or did it just introduce friction? Or did it just introduce detection points? Should we go focus on like a preventative control instead of just detective controls? And so while oatmeal was built internally for detection and response, it's now turned into how do we go to the engineers that own the control environment and have those conversations as well to say like, you could help us. We don't even really need this detection. We'll still have it in case the control fails, but we would rather just stop it here, right? Or make them have to adapt here.
That makes sense.
So just where the control overlaps have the biggest numbers, how we've prioritized where we have detections or control enhancements.
And then how often are you redoing the exercise?
It depends. Like all things in IT, we are trying to work through as many of the surfaces as we can where we can get knowledgeable and willing owners of the different surfaces. And then at minimum, once a year doing a review. But when we do contract renegotiations or if we have an event where a security event or security incident where that vendor or something in that path was involved, we review it then too, to make sure that there's nothing we didn't account for, like there was an unknown in our overlay, or if we can then use it to kind of be the infosec hammer that we don't ever really want to be the hammer, but like the hammer of like, this is what we think we need to adjust in this environment to not have this happen again. Our goal is every year, but there's a lot of environments, so we'll see how often we actually get to do it.
That makes sense. I mean, I can imagine in such a massive environment, it's quite an undertaking. So let's fast forward through the process a little bit. So let's say that you identify some new controls, some new monitoring, you deploy some rules. Have you figured out a really clever way of automating tuning?
No. Tuning is like a sore subject in that it's a constant treadmill, right? Our analysts are always finding, or they're always responding to alerts and saying like, this could be better, or how do we make this better for me? Or every time I respond to this, it's not great. And we didn't have a great data-driven way to know where to focus other than analysts were complaining, right? And being the squeaky wheel. And so we've introduced tagging into our cases so that when analysts are closing cases, and every alert that gets human reviewed becomes a case, they have to tag it. Was the alert right? Right? Just was the logic right? Or did the detection engine go wonky? And then was it a true positive? And we have some subcategories of true positive. Was it like a true positive and benign because we had an engineer doing engineering things or an admin doing admin things? And like, we don't like, that's fine. We don't care about those. Or was it just an okay thing because of that person's role? Or was it truly like a malicious, evil event? And so we have the metrics, we track them monthly and quarterly, like to see how we're trending. And then we can take the data to focus in on the ones where it's like, oh, that was an admin doing admin things, right? Or a security researcher doing security researcher things, which is an interesting problem that I haven't had at any of my other employers, right? We didn't have security researchers just doing things that I would not want people doing anywhere else I worked. And so that's been an interesting challenge. And we have ways to kind of solve those challenges. But until they happen, like until an alert happens, you don't really know why that might happen in your environment, if that makes sense. Like you might build it for one reason. You might have pushed it to production through production review and never had an instance of it happening. And then all of a sudden something changes in your environment and it's happening and it's totally fine. Those are really interesting challenges sometimes, but maybe easier to solve than kind of like admins are doing admin work. That's the tough thing. You've seen the meme of the Pokemon butterfly guy. Like, is this a threat actor or an admin being an admin? And we ask ourselves that a lot. And I think modeling out what people do, like their entity or the groups and memberships they have within the organization, can help us start to make more sense of that and to filter that noise out, essentially, from even getting to our analysts. Today, we have context of like what your job role is that we can associate with each alert, who your manager is, like all of that stuff, where you live. And so for our security researchers, there's a whole set of things that we know they do on a regular basis. Our IT admins, we know what they do on a regular basis. And so kind of post-processing from a detection, we'll go, oh, that's a security researcher. It's this alert. We're actually not going to give that to a human. It's just going to get closed because that's expected behavior for that role. But managing and maintaining kind of that post-processing exception and exclusion list is not sustainable. And so looking for a machine to help us, right? Like some kind of entity analytics, machine learning box to help us make sense of that is something we're working on. And I hope like we can figure it out just to make our analysts' lives easier. I think context is really essential to making analysts' lives easier. But now that we have context, we can even just exclude that from ever showing up in front of an analyst.
Do you typically prefer to just ignore those events completely, or take like a suppression approach where you say, like, maybe you label it and it's like an informational type of thing? Like,
it's still informational.
Okay.
And informational alerts are kind of surfaced as in the aggregate multiple times a day, so analysts can kind of have a pulse of what's happening. We also do alerting on our alerts, even the informational alerts. So those are threshold based. So if you as a user have multiple alerts in some time period, that'll generate an alert, even if none of those other alerts were serviced to a person, to an analyst. Same for your workstation or any other workload. And we can associate you with your workstation. So if the alert happened and it was like, that was Darren, but your email address is not just darren@elastic.co, we can put that together and still generate a threshold-based alert to say, like, Darren's been up to no good, but he can read all of our rules. And so he knows how to fly under the radar mostly.
Darren's at it again.
Always am.
Let's talk a little bit about response. We talked about tuning, and that's sort of still a human in the loop, which I think makes sense for now. Mm-hmm. What about response? Like, what are the commonly reliable response actions that you've been working with that others can listen in and learn from?
Well, one, we do response maybe a little different than most organizations. We have a small team of response analysts for the size of our organization. And we can't keep up with everything. And we can't keep up with all of the technology in our environment. Like, we can't be experts on all the different technologies. And so what we do, and I'll answer the question too, but we operate as a DCERT, a distributed security response team. And so our analysts often, if they're not working on alerts coming out of the detection engine that they can solve themselves, we rely on the experts across the organization and pull them in and essentially deputize them as incident responders. So let's use secret leaks as an example, because they're my favorite thing. Secret leak happens, came out of I don't even know where they would come out of. Let's just say someone copied and pasted it into GitHub and it got committed in public. So we pull in the SREs that own the infrastructure, and they are then empowered to go do all the actions, right? Our behalf to do the rotation and tell us when they did the rotation so we can go assess what happened during the exposure window. And so that's been really successful for us as far as getting alerts to the people who can actually take action on them the fastest and know the most about the system. The other things that we do, and I think this is really powerful, is distributing alerts to the users that caused them. So let's say you added a forwarding rule to your email address. Simple thing, right? People do it all the time. And if you've ever used Google Workplace as your corporate email, you can't just turn that off necessarily as a feature, because you probably built integrations around forwarding email to places. And so we built a response action that says if we detect that happening in our environment, we automatically undo it and send you a Slack message that says, hey, you did the thing. You're not allowed to do that. But if you actually need that, here's the route to go get that implemented and approved, or approved and implemented. And thinking about, how do we do more of that, right? How do we send more of the alerts to the people that caused them and give them the ability, depending on the severity or the criticality of that alert, to either say, yeah, that was me. No, that wasn't. I need help, right? Like, there's something actually bad happening. But then if they say, yeah, that was me, not just taking them at their word, because we know threat actors can be in Slack, right? And presenting them with an MFA prompt from Okta to prove that it's them. And all of our MFA is WebAuthn FIDO2 phish resistant MFA. So the chances that a threat actor are actually going to be able to say, yeah, that's me successfully is low. I think it's not zero, but it's low.
Yeah, that approach is super effective for a lot of reasons. And what do you think is the approximate productivity gain you got from implementing something like this? Like, what volume of alerts were just resolved by implementing?
I just went through QBR the other day, so I have a pretty good idea that we did about 3,700 alerts in the last quarter that actually made it to a human, right? That weren't auto-triaged and closed or something else. Of those 3,700 alerts, almost 2,000 of them were distributed to the people who caused the alert. And if I recall correctly, only about 5, a handful or less, said, no, that wasn't me, right? And then after we went through all 5 of them, it was actually that person. They just didn't understand what they were doing. But think about how much work we avoided doing. We collect, if it's our support team doing something, we can collect case numbers. We can say, oh, that was an action against the cluster that person owned if they were doing something against their own Elasticsearch cluster. that's fine. We don't even have to look at that. So those can be auto triaged and just avoided altogether.
Wow, that's a pretty amazing story, going from basically 4,000 to 2,000, like slicing it in half is pretty great.
Yeah. We calculated like our full-time equivalency savings through our orchestration and automation to be about 55 FTE equivalent over the last quarter, right? Just from people not having to copy and paste and go to like virus total and do all of that. Like all those things are done automatically. And while they might not have been done for every alert that came through the pipeline that gets counted at, it's still a good indication that we're doing a lot of good stuff to save our people from having to do context switching, copy and pasting, and just kind of the tedium of responding to alerts. And I'm hoping with the forthcoming wave of everything AI and RAG and that they'll have to do even less or like nothing at all in some cases, right? Like we're going to have a corpus of data. We already have a corpus of data we've been responding to that can be a good input to machine decision making, right? And saying like, this has always been a false positive. Now, that's probably a good tuning issue as well, right? Like there's probably a tuning need at that point, but for a human has to go make that, like the machine can do that. We can take away a lot of the burden from people and let people do what people are good at, right? Like making decisions, rallying a team, taking action. I'm not to the point where I'm like, let's take the human out of the loop completely or like response actions generically. But I think we'll get there. I think we'll get to the point where people in my role, people that are doing response will be comfortable when saying like, yeah, take actions, just document, like log everything you do so we can replay it, right? And understand and whatever tagging we can do post alert, we can say like, don't let that ever happen again. Or like, this was a good one, right? Like figure out ways where we can tune what happens.
Well, Darren, this has been a really awesome conversation. Want to wrap today's show with some 3 pieces of advice, as we usually do.
Sure.
So what knowledge can you drop on us to wrap the episode?
The first thing I'd say is just everyone stay curious. Don't just take everything at face value when it shows up in your alert queue or in your logs. Ask questions about why they're in your logs, why that showed up in your alert queue, because someone thought it was important. And maybe it was wrong. But keep asking questions, keep learning more. The other thing that's been really successful for me in my career and being in detection and response is do the things no one wants to do. Like pick up the tasks that no one wants to do. You're going to learn so much about your environment. You're going to build so many relationships that help you do better in your environment and know more about your environment to protect it. That's just been a really invaluable thing for me in my career and getting good insights into our environment. And third, it's not even really related to technology, but take care of yourself, right? You can't take care of your estate. You can't take care of your environment if you're not taking care of yourself. You're going to be exhausted. You're going to miss things. You're going to not be curious anymore. So take care of yourself. Take that PTO.
Great advice. You know, it's so funny. I did a show yesterday and there was 2 pieces of repeated advice around staying curious and taking care of yourself. So I think this is a theme in security that we've started talking about.
Oh yeah, for sure. If I look back at my career and even like this is advice for myself, like I should just pin it on the wall. My PTO balance often gets maxed out and then I have to like tell myself and force myself. And I think when I was coming up in my career 20 years ago, it was grind culture, right? Like that was what you had to do. And all of us that did that have learned that that wasn't healthy, right? And so don't look at us as the example. Look at us as like, we're trying to help you not do those same things again as your leaders. And take the time off. Like we're still learning and growing too, like trying to take our own advice, but I would say just do it. And we're here to support you as leaders. And if your leader isn't, it's maybe time for a new leader.
I love it. Thanks, Darren. It was great having you on.
Sure.
Learned a lot from the conversation and hope you all enjoyed listening today. And Darren, are you hiring? Like, is there anything you need to plug?
Just try Elastic Cloud, I guess. I'm not hiring right now.
Love it. Cool, Darren. Thanks. And we'll see you all next time. See you.
Thanks, Jack. Bye.